myself. So I'm Mads Torgersen. I work for Microsoft. I'm the language PM for C#. PM stands for Programming Manager, which is just a word we use. And I'm one of the people who's on the design team for the C# language. So I wanted to talk about dynamic, the new feature in C# 4.0, and I sort of give you a bit of a maybe give you some suggestions for how to think about that as a feature. Like, why is it there? Why does it look the way it does? And what might it mean to you? There's already a session in here, Luca Bolognese's session in the previous time slot, that showed quite a bit of usage of dynamic. I'm going to show you a little bit of how that feature works, but try to more give you some of the underpinnings, both in the form of what the technology builds on, but especially sort of the design perspective. I'm going to take you on a little journey, and that may be a little nerdy, and if you don't like it, tell me so in the evaluations afterwards, but I'm sort of give you a journey through a couple of the design options we had as a design team for dynamic, because I think it may be educating in terms of how to think about the final feature. And I was one of the few people in the room, so I can give you those stories without sort of by being only self-deprecating and without speaking ill about others. So that's a perspective. I want to start out, so the menu is to talk a little about the dynamic language runtime, which is the thing that underlies the whole dynamic feature and the dynamic languages on .NET and so on. I'll talk some about the dynamic feature itself, what it looks like, and then we'll go into this, language design discussion and see what you think about that. I'll try to leave some room for questions towards the end. And if you have further questions after this session, as soon as you're done asking questions, and we'll probably have to cut it off like on time for the next speaker to get up here, I'll head on down to the Visual Studio Languages booth, which is in the exhibition area, and you're welcome to come over there and ask further questions, or if you have anything you want to discuss about C#, the language, or any of our other programming languages, come down there and grab us. We'll be down there quite a lot. Either I'll be there, or other people from the C# team will probably be there, or people from the VB team and so on. So come down there and discuss whatever thoughts you have about languages. And especially right after this session, that's where I'll be. Talking about the DLR, the Dynamic Language Runtime. Let's have a look at what was this thing about the Common Language Runtime? Why do we have one of those? The idea with the Common Language Runtime, as opposed to like a single language runtime or something like that, was to have a shared platform for many languages to build on. So that it's like a shared resource. It lowers the barrier to entry for programming languages, but it's also a great interop platform. Like, these languages should be able to work well together. So it has a high level of abstraction in the runtime itself that you can share through. And that's turned out to be one of the big successes of the CLR so far. That many languages can interop on it. But it does have a limitation in itself, which is that it works best if those languages are static languages. That's like strongly typed, compile-time typed languages. Okay? And so the DLR is really an attempt to do the same for dynamic languages. The DLR is not like a separate component and a separate runtime, really. It's a library that sits on top of the CLR, which is intended to be it's sort of the same thing, except for these call-out things. It's intended to be a good platform for implementing dynamic languages on and to facilitate great interop. And not just among those dynamic languages, but among the static and dynamic languages as well. So it's really more than the sum of the parts here. It's a bigger unification, a grander party, if you will. So that is the intent of the dynamic language runtime. Now, how does the dynamic language runtime operate? What are sort of the components in it? The main thing to think about as a user of the dynamic language runtime, sort of an end user of things dynamic, is the notion of a dynamic object. So what is a dynamic object? Well, it's an object, but it's an object that has a special capability, which is to implement its own binding. In essence, it does its own dispatch. Okay, so a dynamic object is one that knows itself programmatically how to deal with method calls, how to deal with being invoked or being indexed into, and so on. So instead of having like the the fixed semantics of a .NET type, it sort of takes over from .NET and says, hey, I'll handle that. Somebody's calling a method called M on me. I'll decide what to do about that. I won't look for a .NET method called M and just call that. That's what a dynamic object is. So that's sort of the core technology of the DLR, of the dynamic language runtime. And having that sort of core idea makes it really easy to implement dynamic languages on top, because a language like Python, all the Python compiler has to do is to then generate dynamic objects that implement Python semantics. So whenever you call a method in Python, it will call the method with Python-style semantics. And there are things you can do in Python that you can't do with a normal .NET object. Like you can add and remove properties and stuff like that. And this dynamic object can handle all that because it's not leaving it to .NET. It's doing it on its own. Now, you can imagine that doing all these kinds of things programmatically, like doing binding at runtime programmatically, that can be pretty darn slow. And if any of you have experience with dynamic language implementations, they can sometimes be slow. Or sometimes a bunch of people put a heck of a lot of work into making them fast. And one of the big challenges for building the DLR was to make a fast infrastructure underneath dynamic objects that wasn't targeted at a specific language, but that worked in all kinds of different scenarios. That caches and optimizes dynamic code so that it runs at the speed that is near what statically compiled code can run at. And the dynamic language runtime is an API, a public API. Everybody can plug into it. Everybody can target it, not just with languages from compilers, but you can build your own dynamic objects on top of this API. And you can do it in a relatively simple fashion, which I'm going to do in just a few minutes. Luca already did it a bit in his session as well. Or you can do it in a very advanced fashion where you interact with the caching system and so on, and have a really expressive way of deciding when things can get cached and when you have to do a new dynamic lookup and so on. So if you're really into it, you can get a whole lot of performance out of the DLR, and you can also use it for simple stuff and still get a decent experience. So that's the DLR. And now that we have one, now that we have the DLR, it would be a shame to only use it from the dynamic languages. It's such a great asset. And it is and very, very successfully designed. I must say, I can say that without blushing because I wasn't part of it at all. But it's not just a great asset in itself. It really fosters, we hope, a new kind of ecosystem where you can write dynamic code in earnest from dynamic languages such as Iron Python and Iron Ruby and other languages that are starting to target our platform. Like Clojure and other external projects as well. But that means that we get more and more code out there that's written in a dynamic language and that uses a dynamic infrastructure. And without doing something, all that code, all that good stuff out there will be really hard to use from our static languages, from C# and VB. So we have to do something in order to make the interop experience from a static language to a dynamic one as smooth as it already is with Iron Python and Iron Ruby coming to static.NET types, which is a really great interop experience. And that is sort of that's the reason why we do dynamic. We want to open up to these dynamic worlds. It also improves other things other than just interoping with dynamic languages. Sometimes you have object models that are just, you have things that logically, they're just objects. Like they sort of have properties and they have methods and so on, but they can't be expressed as a static .NET type. Maybe because you generate them too late in the cycle when your program is already running, or maybe because they actually really are dynamic. They evolve over time. Now they have this property, now they don't, and so on. But they're still like object-like, and you kind of want them to be more easy to use from C#. If there's something that's a property, why not make it a real property? And finally, we have better COM interop with the dynamic feature because COM has dynamic aspects that aren't represented really well today. So that's sort of the reasoning behind. So the way we do it in C# is with a dynamic type. The sort of language design that allows for this integration is with what we call the dynamic type. Now, if you have ordinary static code like this, you have a calculator type that has an add method. It's obvious you can just go and call that add method, and the compiler will let you, because it knows that a calculator has an add method. Now, say that there was a .NET type called calculator, but you didn't have it available when you compiled, then you have to call it through reflection. And that looks something like this. Okay, that's pretty darn ugly, just to do the same call. But you can do it. There's all kinds of unsafe stuff in there about, it has strings in there and params arrays that might be the wrong length, that have the wrong types in them or whatever. But you can do it. And you're likely to get it wrong the first 10 or 15 times, but finally you get it, and then you go on to write the next one. So that's not a very satisfying way of interoperating, even with our own .NET objects at runtime. Then if you have other object models out there, let's say we have script objects from JavaScript or something, they would have a similarly untyped and ugly way of interaction, but different. Right? So you even have to do different things to call methods on these different unsafe dynamic platforms, and it's that's kind of horrendous. So the idea with C# dynamic is simply to say, hey, let's give calculator the type dynamic, and let's allow you to just call that method on it. Compiler's going to say, I don't know what you're doing, but it's dynamic, so I don't care. Go ahead, be my guest. And it may not work at runtime, but that's not my business. You opted out of my help and guidance. Thank you very much. And you just see what happens, which is no worse than what this code does, what the above code does, right? It does the same thing, except that there's not all these other 100 ways it can go wrong. It's just very concise and very to the point. This is what I want to do. And it can do underneath what needs to be done to make it happen. So what's to note here? It's actually statically typed to be dynamic. Dynamic is a static type. The compiler knows about it. It's kind of funny. What it means, what having that dynamic type on calc means is that when you do things to it at runtime, like calling a method on it, that gets bound dynamically. That means only at runtime does it even try to figure out what you meant when you say add. It will look at the actual runtime type of the object. It'll say, what are you? Are you a dynamic object? Oh, if you are, then I'll go and ask you to do the whole work. I'll just say, you do the work. You're dynamic. You handle your own method dispatch. .NET's out of the business. It's your problem. Do it programmatically. And it may use caches and so on to do that. If it's not a dynamic object, then all hope is not lost, because it could be an ordinary .NET object that has an add method, which would be the case in sort of the left version of the code up here. And it will call essentially what's called a C# binder. It will call a runtime component that's part of the C# compiler that lives onto runtime, that knows how to bind stuff, just like the compiler did, but it just does it later. It does it while the program is running. It says, OK, I've got this stuff here. It has this runtime type, and it's not a dynamic type. So can you just bind it as if you were the compiler and you knew it had the type all along? And it will go and do that. OK, so that's kind of like the mechanism underneath. Now, once you bind something dynamically, typically the compiler can't know what comes back either, because it doesn't know what method you were calling, so it doesn't know the return type. So the type of that will recursively be dynamic too. And that means that the next thing that happens to it, which in this case is an implicit conversion to int, that will also be dispatched dynamically. OK, so that's a dynamic implicit conversion in there as well. That's a feature in a nutshell. And now we'll sort of go into more details around that. But before we do, let's have a look at how it works. So Visual Studio, nothing in my sleeve, clean program here. I'll start out by using system.dynamic, because what I want to do now is, I don't want to do Python interop or something. I want to use show some of those facilities to write your own dynamic object, so to give you more of a feel for what a dynamic object is. System Dynamic has a great number of nice helper classes, including some common kinds of dynamic object. One really common one is called Expando object. An Expando object is essentially an object that has nothing on it. It's an empty object until you assign to one of its properties. Then that property magically appears. And after that, whenever you ask about that property, it will return you that result. But if you ask about a property that you have never assigned to, it will throw an error. It'll say, I don't have that kind of property. So you can go and use that directly. You don't even have to write it, even though some of the demos around will show you how to write it. So I can just say dynamic. I use a dynamic type here, D equals new expando object. Okay? Create an expando object. And now I can say D dot, give me a property name. Foo! Oh. Thank you. I'll pay you afterwards. It only works with foo. It's only been tested with foo. So d.foo equals bar. Let's make it a string, huh? And then, of course, if you write out the result of d.foo, hopefully my program runs, compiles at least, and lo and behold, it writes bar. Not very exciting. Actually, probably the more exciting thing is that if we type it wrong, we still get it to compile, because I may be accessing a property, but I'm not getting it checked at compile time. So when I run it, what happens? I get an unhandled exception that says, oh yeah, it stopped working. Surprise. That says the runtime binder, the expando object does not contain a definition for foo. That's just the error the compiler would have given me if I had a strong type that corresponded to this, if I was looking for a property that wasn't there. So it's really doing the compiler's job at runtime. It's pretending to do so, even though this was a dynamic object. It gets me my compiler's error messages only at runtime. I think it's kind of cute. So that's like an example of using expando objects. You can write your own kind of dynamic object as well. That's the difficult way of doing it. There's an interface called dynamic meta object provider. Did you get that? He got it. It's a long interface name because you're not supposed to use it very much, and definitely not throw it at users, which is an interface that allows you to go and implement all the logic around caching stuff and so on, so you can have a really fancy dynamic object that is really efficient and so on. And that's what the Python objects, they all implement this interface directly. But there are some simple implementations of it that you can derive from if you want a simpler experience. So I can say class my dynamic object here, inherit from dynamic object. There you go, dynamic object. And then I can override methods that handle different kinds of lookup. So I can be the compiler. It's kind of cool. So let me say override. What can I override? Bunch of methods here, kind of small font. You may not be able to see it at the back, but let's try this and try that. Try binary operation. Try convert. Try get index. A couple of things also that you can't do from C# syntax because some of the dynamic languages support that. But you could essentially, I can ask somebody on the front row who can see the small print, what kind of thing would you like me to implement on this object? I can invoke it as a delegate and say what happens when this object gets invoked. Somebody have? What's that? Try unary operation? Yep. Let's take that one. Try unary operation. So you override that. You get an out parameter where you provide the result of doing the unary operation, and you get a binder that contains information about what the unary operation was, and then you return a bool which says whether you succeeded or not. So we can say something like what we're going to do, of course, is console.writeLine because we're in a demo at a conference. So console.writeLine. Let's see if the binder has some interesting information for us there. Binder operation. That sounds like the right thing. Let's print that out. And then we have to return a result. So let's say result equals null. And we have to return whether we worked or not, and we did, because we accepted the binding. And so now we can go and use my dynamic object here. And we can try to use a unary operator on it. So let's just delete all this stuff and say, what's a unary operator? What's that? Increment. D++. Good thing we didn't call it C. Let's see what happens. This is always dangerous because I printed out the operator. Isn't it cool? So, I mean, look at the C# code. It just does the increment operator. And then the dynamic object here goes and intercepts and says, I know how to handle that. I'll just print out what operator you used. And so you really have some fantastic ability to seed object behavior in C# at the cost of static type safety, of course. But you know, who cares about that these days? Back to slides. So that's a dynamic feature and a bit about how it works under the hood. And now, so I'm going to, haven't done this at a big conference before, but I'm going to actually talk about why it looks the way it does. And that may be incredibly boring to you, in which case you have to remember that this is charity. I think it's the local Boys and Girls Club. They get money whenever you put in evaluations. So you should go and do that for some other session. The thing about putting a dynamic feature in C# is C# is not a dynamic language, and we don't intend it to ever be anything like a dynamic language. It's a static language. That's the feel you should have. We're committed to that. And the sort of initial knee-jerk thing for us was to sort of say, oh, our users, they're going to be scared, something less, of a feature like this. It's going to be weird and dangerous because it's not statically typed. So we got to really encapsulate the illness here. We got to very explicitly show here's something bad. Like here's cancer in your code. It has to be evident from the syntax. If possible, it should be like glowing, pulsating orange or something like that, because it's really dangerous. And therefore, it should be syntactically explicit at least. And that was sort of like our starting point as a design team, being conservative as we are, right? Being designers of a static language, that's sort of, one of the first 3 questions on the questionnaire when they hire us. So we went through a bunch of designs that try to fulfill this principle of making dynamicness syntactically explicit. Here's fully statically typed code, and I'm going to now try to see what would the dynamic version of this code look like with the hypothetical design of the features I'm going through here. So I just get an array of strings here, and I get the last element by subtracting 1 from the length and indexing. And let's assume that strings was something I got dynamically instead. I didn't know whether it was a string array or just something that maybe behaved like a string array. It might be a dynamic object that implemented its own length and indexing and so on. So I only know it's an object. Assume we don't have dynamic typing here. This is before dynamic type. So what do I need to do to my strings indexing expression down there in order to make it dynamic and to make the compiler happy? Well, I have to explicitly say every operation that's dynamic, I have to explicitly mark it. So let's say there's some squiggle we haven't used yet in the language, maybe a tilde, that I can use to mark that the dot I apply here is a dynamic dot. Okay. So I put a tilde in front of everything dynamic. Now it's syntactically explicit. Nice. And we're also doing another dynamic thing to strings. We're also indexing into it. So let's put a tilde in front of the indexing as well. Nice. Okay. Oops, but hang on. What comes back from strings tilde dot length now? We don't know. It's probably just object, because who knows what it bound to. So the minus there cannot be resolved statically, so we need to do that dynamically as well. Oh, okay. Okay, what comes back from the whole thing? I don't know, because I just indexed dynamically. And I don't even know what the thing is in the first place. So I probably have to convert it to string. Okay. But it might be something that actually implements an implicit conversion to string. But I don't know, because I don't know what its type is. So I should probably do the conversion dynamically. So I can ask its runtime type, do you have a conversion to string? And not its compile time type, which is object, which would get the wrong conversion. It would try to just do a reference conversion, right? So that's sort of how that first one went. And no need to say it doesn't read so well. But it kind of showed us something that dynamic often travels in packs, right? You often get, once you have something dynamic, it sort of gets all dynamic for a little bit, and then it sort of peters off, which is why we need to put all these dynamic things in there. And so that gave us the idea, maybe we should just take and wrap up those bunches of dynamic, put them all in a context of sorts, like we do with unsafe code. Like let's wrap it up and put it to a side, and people can see here be dragons, and we're not saying where the dragons be, but you know, they're in there. So that would look something like this. We have a dynamic context, right? Like unchecked or unsafe or something like that. And inside, we can do the dynamic things. And everything we do in there is dynamic. So if you squint, you can see that some of it is red. It's because it's being dispatched dynamic. Because this IDE I'm using up here in PowerPoint can show you when things are dynamic, as opposed to the one we're shipping. That's sort of OK to look at. But it runs into its own problems with scale. I'm not going to sort of show something that grows big here. But first of all, like it's a different dialect of C# inside. When you're inside a dynamic block, indexing means something different. Minus means something different. Dot means something different. Everything means something different. That's kind of, it's like a whole other language in there. We're certainly not in Kansas anymore. So sometimes you want to say, OK, almost everything here is dynamic. But this one isn't. Like, do you put dynamic or context around all the other stuff? Or do you have like also a static context that you can nest inside a dynamic, and inside of that you can nest some dynamic? It's just not very manageable. And also, if you get like these contexts might be big. People like saying, yes, we can party. C# is dynamic. Let's just say dynamic up here and end curly down there, and we have a different language, and everybody's happy. But then you can't look at a screen full of code and see that it's dynamic because it's a dynamic up there and it's outside of the screen. And so it doesn't really work. So next try. OK, we can't envelop it from the outside. Maybe we can sort of start from the inside. After all, that's where it started. It started with that strings object. That was the thing where things started to get dynamic. Maybe we can make it bleed out from there. OK, so the idea here is to say strings was, so to have the idea of having contagious dynamic expressions. That's what we call them. Like, you can say that an expression is dynamic, and then the dynamicness sort of spreads to the expressions that it is part of. OK, so we say explicitly strings is dynamic. And then it spreads from there. And therefore, everything up to the statement level is dynamic. Now we're sort of getting to something almost familiar. But just having this separate notion of dynamic expressions doesn't really scale again. First of all, like, what are the rules of propagation? When is it contagious? But also, like, what if I want to factor out a sub-expression, right? Well, then when I call that sub-expression, so inside of that sub-expression becoming a method body now, then I have to say dynamic in there, but then I also have to say it where I call it. And so I can't really get this propagation to go across call boundaries and so on. And of course, what this really means is we're almost there. This means that we do have a way of making dynamicness travel with objects across method boundaries. It's by putting it into the type system. And when we looked at a bunch of examples of existing dynamic code, like we look at Visual Basic, we look at IronPython. Visual Basic it has late binding, right? So there's some dynamicness in there. We sort of like, typically, a given object is treated as dynamic like all the time or not at all. Okay, so it really makes sense that a reference to that object is where you say, treat this bugger as dynamic whenever you treat it. Right? It's just the way it wants to be treated. And these other guys, let them keep their static types, and then they're as static as they ever were. And that's how you derive, when you do something on a dynamic thing, that's how you find out whether that operation should be dynamic or not. It's whether it's applied to a dynamic thing. And that really resonates with all the examples that we looked at in existing systems, and it also just becomes really nice, because at the end of the day, dynamicness follows the object around, and there's no syntactic difference left. But oops, that was sort of the premise that we started out with. We wanted it to be syntactically different. So how do we sleep at night? How do we resolve the moral dilemma, the boiling inside, the shame? Like, how do we avoid having to whip ourselves every night for having sinned? For this joy that we feel it, and so we kind of need good excuses. So having enjoyed this together, like, that was good. How can we justify this? I think that there are a couple of things that really resonate with me here. They were kind of after the fact things, but I've sort of internalized them now, so I can speak almost without breaking a sweat about it now. it's still explicit in the code. Dynamicness is still explicit. It's just not in the syntax. How's that? Like, how can it be explicit and not in the syntax? Well, we've tried that before. We've been here before. In C# 3.0, we introduced the var feature, which allows you to declare a local variable and not say its type. And what we said was, this doesn't matter. It's still safe. Even you can't see the type, you just hover over it with the mouse in the IDE, and it tells you the type. It still knows the type. Okay. And same thing with dynamic. You might not see the dynamic type because it comes from somewhere else. Like you do a method call, and it returns dynamic, and it flows into expression, and you can't see the word dynamic anywhere there. But if you hover over any of them, you can see the word dynamic. Type dynamic is right there. So it's still explicit. We just have to think, we already started to think a little bit differently about explicitness. It doesn't have to be in syntax because people don't write code in Notepad. How many write code in Notepad? What's the one? Okay. This one, yeah, okay. Most people don't write code in Notepad. And so, and you work for Microsoft anyway, it's cheap. And so you do have tools that can tell you these things really easily, right? And the other thing is, remember that slide with the bad code and then the dynamic code at the bottom? Like, it replaces some, it's intended for interrupt at the bottom of things, right? It's for code that was worse before. And finally, and the thing I really like most about it is that we are really embracing dynamic. We're not treating it as a second-class citizen, as a cancer over in the corner. It is really the real thing. And we are fully embracing. And that feels good to have found a solution where we're still a static language. We still have a static type system, but we're fully embracing dynamic. We're not just treating it as a second-class citizen. I've repeated that to myself long enough that I truly believe it. So that was sort of the main design question. What is the model here? It travels with the type. Dynamicness travels with the type. It travels with the object. Okay. Compiler tracks it through the reference to the object, and that's how dynamicness comes about. There are a couple of other things you have to decide about this feature. One that was actually giving us a bit of grief was this question. Is dynamicness, it travels with a type, but is it a type? Or is it a type modifier? Can you take any type and get the dynamic version of it? The meaning being, I have this page, like HTML page is a really good example, right? It has some static stuff on it that you want to be able to access in a statically typed way. But it might also have scripts in there or something that you want to access dynamically. So you want to have this hybrid object maybe that if you say dynamic page, that means everything you can, dear compiler, please resolve it statically. But if there's something you don't understand, don't give me an error, resolve it at runtime. Okay. That was a real design option until we started thinking about, like, first of all, this is relatively rare, and there's an easy workaround. Like, you can have two references to it with a strong type and with dynamic. And also, it just really complexifies the language. Like, think about generics and having two versions of each type. Like, so you would have list of dynamic foo, and you would have dynamic list of foo, and you would have dynamic list of dynamic foo. And what does it all mean? It sort of gives you a headache, right? And you don't really want to get a headache from static typing of a dynamic feature, essentially. That's just not fair. So here we went for simplicity and said, it's a type. And when you have the type dynamic, everything is dispatched dynamically on it. That's it. And you can work around it. Then there's a question of which things sort of trigger dynamic binding. And many other systems that mix dynamic and static, like VB and Objective-C, which has come to prominence again recently because of some other thing, you typically focus mostly on having a dynamic object and being able to use it as a receiver for a method call or property access or maybe an operator call or something. Okay, so that's the important use case. And that's the same for us on the DLR. The important core interrupt case is take a dynamic object and call something on it. But what we have to think about is that what happens after you call something on that dynamic object? You get something back. It might be another dynamic object, but it might also be just a .NET object. And you sort of want to ease your way back into the static world, because C# is a static language, and that's where we want to end. We want to end back in static. And having to say immediately, as in this example here, I get a D back from, it's a dynamic object, I got it back from some dynamic operation, and now I want to get the absolute value of it. Having to say that now getting back to static and calling a method with that as an argument has to be statically resolved, that forces me to give it a type. But I might not, I want to call whatever apps fits it. I want apps to be dispatched dynamically as well. I want to gently get back And then at some point, maybe I do a conversion or create a new object or whatever that gives me a strong type, and I'm back in static line. But I don't want to have this hammer. Boom, you can't do that. You do this dynamic over here, but you can't do that. So you can do, so what that means is that whenever any sub-expression of a method call or anything is dynamic, we delay the binding to runtime. Okay. It's more general, maybe more surprising at first, but it's really smoother that way. And then that gives us a really general feature here. Like you have all these different operations. You can dispatch method calls dynamically just because they have a dynamic argument. You can invoke dynamic objects. You can index into them. And whenever you do that, you get another dynamic back, something that's typed as dynamic from the compiler's perspective, but may not be a truly dynamic object. And then there are a few operations you can also do that actually give you a strong type, even though they're dispatched dynamically, because they say what their type is. Like conversion, implicit or explicit conversion, well, you know what you're converting to. And so that's how you get back into static land. And also, actually, if you call a constructor on a known type with a dynamic argument, that constructor gets overload resolved dynamically. I don't know how often you're going to use that, but it's there for completeness. How dynamic is dynamic? I'm soon through with all these design questions. How dynamic is dynamic? Dynamic really means dispatch based on the runtime type, right? Dynamic dispatch means take the runtime type instead of the compile time type and use that. But here's a call that we definitely want to dispatch it dynamically, because we just said it has a dynamic argument, we dispatch it dynamically, but it also has a statically typed argument of type foo, I presume. And it may, like, statically it's of type foo, but it may really, foo may be an abstract class, and it may really be of some much more specialized runtime type. Do we want to use the runtime type or the static type? You might want to say, yeah, we know more. If it's use the runtime type, we have it around. When we do this binding at runtime, why not use the runtime type? But we actually decided that when you have a compile time type in there, that's the one you use. Even though you squirrel it away and save it until the binding happens at runtime, you do actually go through the trouble saving the compile time type and using that in the binding. And so the overload resolution of M happens on the basis of the compile time type of getFoo and the runtime type of D. Okay. And that's really so that you have just really to make it as little dynamic as necessary. Right? You don't want to be more dynamic than necessary. This is purely dynamic enough, and it has this principle of least surprise. Whenever an argument is of a strong type, then that is the type that gets used. If you have a strong type on this, nobody's ever going to look under the skirts and grab that implementation type that you had. Nobody's going to make a decision based on that. That's the promise of this language feature, which is a nice property. Okay. So all this sums up to say is what dynamic really means. The dynamic type means for this object, use my runtime type for binding. If you don't have that type, your runtime type is not going to get used for binding. So that's really what it all boils down to. So something for you, that's it. That's why we designed dynamic the way it is. And I just wanted, the thing I wanted to leave from here with is just, if you have any skepticism about dynamic, just remember this. Like, what would you rather have in your code? What would you rather write in your code? Would you rather write the thing on top, or would you rather write the thing on the bottom? Because that's what dynamic is really for. That's a core feature of dynamic. That's the core scenario for it. And so with that, I just need to go through these stock slides here. All the related language sessions, 2 of them already happened. Luca was in here last session. Dino has been going concurrently with me in a new concurrency, a dual core kind of feature. Also talking about dynamic in a different scenario, though, dynamic languages. So please recall that you can get all the sessions, I think, 24 hours. You can get them from Channel 9. So you who chose to be here instead of with Dino, you can still get his session about these dynamic languages I talked about. What can you do with those? Lucian talks about Visual Basic tomorrow. There's F#, an F# talk about parallel and asynchronous programming on Thursday, and also some ID talks about C# and Visual Studio. Do fill out your evaluation forms, or you will be flogged and drawn and quartered. And go to Channel 9, because all the stuff is there, plus more. I love Channel 9. Go there. And that's it. Thank you very much.